In this video, I'll give you some tips for solving the ALEKS problem called Identifying Important Physical Properties of Liquids. There are a ton of different versions of this problem, tons. In every version of the problem, you're going to be comparing two different liquids. You might get a single picture, you might get a couple pictures. In my situation, I had this one window with a slider. I could drag the slider through and I could watch kind of the progression of these two liquids over a period of time. I took a couple of screenshots and just pasted them onto this slide. So normally it would just have one single box. Some of the variations of the problem I saw had a data table, no pictures at all. Like I said, lots and lots of different versions of this problem, but in every version of the problem, you're gonna have two liquids that you are watching or looking at data and comparing the two liquids to each other. And it's asking you to identify what is different about the two liquids. What property do they have that's different? There are only three possible correct answers to this problem. One is viscosity, one is surface tension, and one is vapor pressure. And so that makes this problem not quite as terrible as it initially seems like it might be. It's also not asking you to compare the two liquids, like which one has a higher viscosity or higher surface tension. It just wants to know what is the property that is different. So what I'm going to do is just talk a little bit, just give you a little bit of a brief description of what it might look like if you have two liquids that have, for example, a different viscosity. So viscosity is just going to be giving you information about the flow of the liquids, and that could either mean the liquids themselves pouring out of something. So you could be comparing liquids pouring out of a container, or I think I saw one where they were being poured through a funnel. And you could also see, like in my case, you could also see objects moving through that liquid. So objects moving through. In my problem, I've got like ball bearings or something that are moving through the liquid over a period of time. And so since I can see that this liquid, the object, the ball bearing moves quite a bit faster, and then in my other liquid, the ball bearing moves quite a bit slower. So that means for my ALEKS problem, the answer here would be viscosity. That is how the two fluids are different from each other. Another option is that you might be looking at comparing surface tension of the two liquids, and surface tension is really giving you a comparison of like the surface of the two liquids. So you're going to see something like I saw one where an object was resting on the surface. It was a bug resting on the surface of a liquid. I saw another surface tension problem where it was a droplet of the liquid that is it's like it was being pushed by air, or it was falling through the air or something along those lines. So it would be a droplet, and it was showing like the varying shape of that droplet as it was being pushed through air. Like one droplet was staying pretty rounded as it was being pushed through the air, and one of them was kind of flattening out. So for surface tension problems where surface tension is the correct answer, you're either going to be seeing objects that are resting on the surface of the liquid, or you're going to be seeing varying shapes of the liquid as something is blowing up against it or something like that. Then the last possible correct answer for this problem is vapor pressure, and this has to do with evaporation. And so for vapor pressure versions of this problem, you're going to be seeing two liquids, and they're going to be going across a period of time. One of them is going to be evaporating at a different rate than the other, and that's really all I can say about that. The vapor pressure problems, there's just going to be comparing evaporation or the liquid moving away. I guess it could also, I only looked at about 10 versions of this problem, but a vapor pressure problem also could be one where you are comparing the smell of the two liquids. I didn't see that in any of the ALEKS problems, but it could be there as well. So good luck with this problem. Again, you're not trying to compare which has the higher or lower viscosity. So you're just sort of looking at, are you comparing objects in terms of how they flow or how objects flow through them? Are you comparing object or liquids in terms of the shape of the liquid or things resting on the surface of the liquid? Or are you comparing the liquids in terms of their rates of evaporation?